Hello YouTube, so in this video I am going to tell you what I did to swap this GS6-37DZ BMW Gearbox into my W463 91G wagon. But first let's take a look at the gearbox itself. So this is the left side of the gearbox. Rear of the gearbox with output flange, a stick for the gear shifting mechanism, and at the bottom you have 4 holes for the rear mount. The right side of gearbox, and at the front there is obviously a bell housing with a spline intake shaft. So this is basically it. Painted and rebuilt gearbox, but it got pretty big mess recently because I've noticed some strange sounds from inside this gearbox, so I had to take it out, and I will have to take it for a check. So basically I will try to make this as fast as possible. I mean this intro about this gearbox, but what I can tell you is that I've done pretty a lot of videos previously about this gearbox when it was in the car, but now when I took it out I understand it's pretty good opportunity to make this video when the gearbox is out, because I'm going to speak about 12 issues and problems, whatever you call it, and to speak about them, I mean to speak about some of them is good when you have the gearbox inside the car, and for some of them it's good when the gearbox is out. So because I have a couple of videos made earlier, so I think I will mix those videos, so I hope you are not going to be confused. So first let's start with the adapter kit. Alright, so you start with buying this adapter kit, and this is mother of all those 12 problems and issues you have to solve. So when you buy it, it is actually the most easiest job, because you just sit in front of the computer and you click, and then you get this adapter plate, which is this one over here. Then you got this single mass flywheel, a pressure plate, and inside over here you can see a clutch plate. So 4 parts, a couple of screws, I mean bolts like those, for example, or those that I'm going to speak about in a while, and this is super easy. It fits perfectly, no problems. You just start with a flywheel, for example, then this plate, clutch plate, and a pressure plate, and this is super easy. Plug and play, no problems at all. Okay, so now this is something that you are not going to get in the kit, and it consists of 3 parts. So you have this spring over here that holds this I don't know, this arm, and then you have a pressure bearing. So all these parts are working like so, right? And over here you have yet another part that is releasing the clutch plate. So what you have to do, you have to buy this pressure cylinder from BMW, and then you have to buy these 3 parts. And what's most important, that you can take it out and you can actually turn it 90, and what you can see is that there are those blocks, and the one pair is smaller and the second is higher. So what you want to do is you want to use those smaller ones. So it fits like so, and then of course it goes like this, like so, but this is something that you put into your gearbox, so let's check it out now. Okay, so this spring wraps around this plastic support. So I'm not going to put it in, but I will just show you the idea. So yes, this plastic pin holds. Then you have to wrap this spring around this plastic, so it holds like this. And then from this hole you have that pressure cylinder that is engaging and disengaging this pressure bearing. Okay, and one more thing, all these parts are available at your BMW local dealer, but it's not that easy to get there and just ask for these parts. So I found one vehicle identification number that I'm going to provide in the screen right now. And this vehicle had this type of gearbox, and whenever I go I use this vehicle number, and I'm buying those parts with using this vehicle identification number. So it is pretty convenient, because then you don't end up in a situation when you have to explain that you have explain that you have BMW gearbox in Mercedes, and well, this is always confusing. So it's better to go with a vehicle identification number in your hand and ask directly about these parts. Otherwise they think, I don't know, like you are trolling them or whatever. So the issue number 1 is actually optional. You get these M10 bolts from the kit, and this is something that I didn't like, because you use these M6 hex and they love to slip. So I bought these torx bolts M10 as well, like this. So they are much better, they are much more reliable. So you have like 1, 2, 3, 4, 5, 6, 7 shorter. Okay, so in this one you have about 25 millimeters of length, and there are 7 of those, and up there you have two 70 millimeters long bolts to undo the starter. And actually this is to change these bolts into torx key is, like I said, optional, but this is something that I wanted to do. Okay, so the issue number 2 is the starter. So the starter in a Mercedes engine is located in a different place, and well, this is actually not a surprise. So what you have to do is that you have to cut out pieces of aluminum in your BMW gearbox, and I knew I would have to do that, but once I did it, I wasn't happy about this, and I started to search for the solutions in my head. But it's actually the issue number 2 is connected with the issue number 3, and the issue number 3 is that when you bolt your gearbox to this plate, you actually override this bolts plate to the engine, right? And actually once you do that, like so, with the gearbox, so then you are not able to undo the starter with these bolts, and you have to take down the gearbox to undo the starter. And what a terrible news is this. Secondly, when you cut pieces of aluminum out from your gearbox bell housing, then you end up driving with exposed starter, and come on, how embarrassing is this? Alright, so this is the factory BMW housing for starter, and this is my housing. So what I did is I cut away pretty a lot of the BMW factory bell housing, like up to here and up to here, and I went to a machining shop and I asked them to turn this, but this was actually a fail. So these are smaller, but my idea was to weld these aluminum tubes inside here and here, and what you can see is that this bolt can go through. So you can imagine those 2 bolts for the starter, like so, and I can very easy, of course this is just an example, insert key, I mean not a screwdriver, but my torx key, and undo this bolt, like so, and I can undo the starter without undoing the gearbox, which is super convenient. And additionally, I also covered my exposed starter. Alright, so to give you experience of unbolting this and to show you that I'm not fooling you around, I will try to undo this bottom bolt, which is simpler. Alright. Oh yes. Okay, so I unbolted it, and actually it was pretty easy, I have to say. Okay. Now let's bang it out, and yes, here it is. So this is the bolt that bolts starter. I galvanized it, so now I can put it back together with the starter, and yes, this, oh yes, this works as well. What a perfect solution. Oh yes. So by doing this I sorted out two more issues, number 2 and number 3, which is exposed starter, which I didn't want to have, and I wanted to be able to undo the starter wherever I want, whenever I want, without throwing down the whole gearbox. Now, issue number 4 is that you must be able to shift gears, and to do that you press clutch pedal and then you run this clutch master cylinder. It has a brake fluid container. I mean, this is completely separate installation against brakes system. But in this tank there is a brake fluid, and the installation is super simple. So it consists of this single line that goes directly to the gearbox. So once the clutch pedal builds pressure in this master cylinder, this pressure is transferred via this line to the gearbox. In the gearbox there is this part, and this receives pressure from clutch master cylinder, and it presses the press bearing, which in turns presses the clutch pressure plate. And what I sort out is that it works perfectly with this Mercedes master clutch cylinder. And actually till now I made a pretty short test run, but what I obtained is that I am able to shift gears. So this is actually pretty easy to do. Well, I call it issue number 4, but well, this is actually yet another connection between two worlds. Well, yeah, you must connect this Mercedes master clutch cylinder with this guy, but in general they seem to work together. So issue number 5 is reverse light sensor. So in factory, this sensor is located inside the cabin next to factory gear shifting mechanism. But in BMW solution, I mean in BMW Gearbox, the reverse gear sensor is located over here inside the gearbox. So what you have to do is you have to throw away the factory gear shifting mechanism and this factory sensor as well, and you have to take that cable and connect it to this sensor. And what I did is I bought this connector in my local BMW dealer as well, and it consists of 3 parts: this rubber boot, this connector, and these copper connectors inside. So you can do your own cable. So this is just cable from some, I don't know, web shop, and you can do your own wire. But basically what you have to do is you have to connect those factory cable to the sensor. So this is the sensor itself with a copper washer, and then this connector. And this is actually something that I like a lot, because it is super easy to click. So what you have to do, you have to just press this spring and it goes super easy. So I really like it. So no screwdriver involved in taking this off. So this is something that I super like. So this is actually very easy issue to sort out. Alright, so issue number 6 is about gearbox ventilation. So this gearbox comes obviously from passenger car, and passenger cars are not supposed to drive deep in the water. To vent the gearbox in this BMW gearbox, there is actually a very small air vent, which is like, I don't know, maybe 12 or 14 millimeters wide, and it's super thin wall, and it has just a super small hole at the top of it. Of course I wanted to keep off-road specification. I mean, I wanted this gearbox to have the same vent style as in my factory gearbox. So what I did, I went to my again local BMW dealer, and I bought a new air vent. So it's like, I don't know, maybe 2 centimeters long. And I also bought steel angled fitting. Well, this is actually aluminum, but you get the idea. And I welded this portion of fitting to this factory BMW air vent. I pressed this in, and I also made vent at engine side, and I connected it with a flexible hose. Well, in general, I recreated factory solution from my OM603 engine and gearbox. Okay, so I covered 6 issues, 6 to go, so we are somewhere in the middle, but now because I have this gearbox out, it's good to get out from under the car and just take a quick look at the rear of the gearbox, because we are getting closer and closer to issues that are concerned with the rear. Now just let's take a look at first at this reverse sensor. So I will just give you a quick look how you are supposed to install it. So it just bolts that easy, like this. And I've also made this hole over here because under the car you have a drive shaft, front drive shaft over here, and I didn't want this wire to get into this drive shaft, and I made this small hole over here. Alright, so here at the right side, I mean all those parts are outcome of my actions, and all those parts here were also part of my deal with DP UK, because once you switched using adapter plate, I mean you switched from Mercedes world to BMW world with the adapter plate, you have to come back from BMW world back to Mercedes, right? And you have to also have ability to shift gears, and to do that I've ordered also this part. So this comes from DP UK, those parts as well, and these parts. So I will put it on the gearbox for you. So this is actually pretty simple, but let's go with this one. So this is something that, yes, came from DP UK that I've ordered. So inside there you have just a round piece of foam. So you put it like so, and then you put this pin inside like so, and then you are supposed to move this securing spring to this position, and then this pin will be locked. But I am not going to do that because I will have to take this gearbox for a check. So this is just a temporary mock-up for you. So now this is something that yes, DP UK sent me as well. So you do this like this. Yes, and then you obviously bolt it to the end. Now from the other side. Okay, so I'm not going to drive these bolts to the end, but basically you get the idea. And this is something that came from DP UK as well. So you press it in. All right, and then you secure it with this one, and you are also required to secure this shifting mechanism with this lock like so, and then and then like so. Yes. Okay, and now this is something that came from DPUK as well, but I did not use those three things. So this is something that I will explain later in videos, and instead of those I make my own. So as you can see, my own is much longer, and this one has bigger boot instead of this. What you have to remember is that you have to take those that are super flexible, because if they are going to be from hard rubber, this hard rubber will shift out gears for you. So in this DPUK stick you have grooves, and this is actually very convenient solution. So you have grooves like this, and then 8 of those O-rings. Here you have a hole and a matching hole over here, so they have to match like this, and then you are free to shift. And I have to tell you that this shifts really nice. Yes. Okay, so this is the shifting mechanism that sits on the top. Now this is something that I am going to talk later, but this was yet another part of my deal with DPUK. So I will talk about this later, but for now you can see it from, when the gearbox is out, and what it does, it accepts the new drive shaft like this, and this drive shaft connects to this input flange of transfer case, which I also had to take out. Okay, so now this is something that I am going to speak as well from under the car, but you can see this is the factory BMW and this is mine, so I kind of copy it, and what you do, you bolt it, not with this one, but with this one, like so. So I am going to use maybe 2 bolts is enough, just to show you, like so, and then you have those 2 bushings like this. Right, so I will set it up for you entirely. Okay, now I will put that railway. Now let's put this drive shaft. Like so. Okay, and this is something that I also fabricated. So you can see those points where you grease the drive shaft, like 3 of those in each drive shaft, and after you do that there is grease all over the drive shaft, and once they spin with a pretty big speeds, like they split with the grease all around, and what I was afraid that I will end up with a bunch of grease under this, I mean inside this boot. So I ended with this one, and as you can see it's already dirty with grease. So where is this? Here it is. Okay, so you bolt it like this. Okay, and those two as well. So 2 bolts. Okay, more or less. So to make a summary, at the top you have shifting. You have a shifting mechanism, right? Then you have drive shaft cover. Then you have flange from gearbox to drive shaft, shorter drive shaft, and gearbox mount, and then 2 bushings. Alright, and the last thing I would like to speak before I jump back under the car and to the previous videos is I would like to measure for you. So this is something like 265, this new drive shaft, and this drive shaft from the factory G-Class is almost like 446, let's say, millimeters. So this one is much longer, and as well it's also important to look inside those pockets, and this is something that I am going to explain later, but for now what you have to see is that this pocket is not that deep as this one, and then I felt into problems, because when you look at this flange it has that huge spacer, and this spacer with this bolt does not allow you to fit this, to bolt this flange into this flange, because this one is just too big. So what I had to do, I had to add a spacer between transfer case intake flange and this drive shaft. Alright, so now after I mocked this rear end for you, I am going to show you previous videos, and it is going to be for you much more convenient to understand further 6 issues. So issue number 7 is about rear gearbox mount, and this is pretty complex problem. And I think it needs explanation, a little more explanation. So in factory there was, you can imagine that there was output gearbox flange and input flange of transfer case, and these two should work in parallel. I mean, the best way for them to work, I mean for the drive shaft to work, is when these are total parallel. I mean, the more the angle is like so, the worse for the drive shaft to operate. So what I did is I measured the difference in the factory angles with this angle finder, and I think I measured like 3.7 degrees difference between the factory output flange and transfer case input flange. And this is super important because once you get like really crazy differences over here, you will fall into serious problems with drive shaft vibrations. So once I knew the factory angle between factory gearbox and transfer case, I started fabricating rear mount of the gearbox. And I wanted to be clever actually, so I went to my BMW local dealer once again and I bought this. So this is the factory mount to the gearbox, and this was actually a fail because you bolt these two bushings to this factory BMW mount. And this is actually pretty clever because they are angled like so, and they work against each other, and that's why I wanted to use it. But once I installed it, I realized that this mount is going to hit this front drive shaft. So this was a fail. In the end, I didn't use it. So based on this factory mount, I made my own. I also used these two rubber bushing, and I also fabricated these rear gearbox mounts. And based on what I've told you about flange angles, I made this mount to somewhere less than 4 degrees difference. So I think this is one of the most important things in the whole swap. I mean, to keep the best angle between these flanges, so it must be as parallel as possible, and it's pretty simple to achieve because this is just a matter of rising on or lowering the rear mount of the gearbox. So issue number 8 is about this adapter. So once I switched from Mercedes world to BMW gearbox, I have to switch back from BMW back to Mercedes again. And in order to achieve that, there is in BMW gearbox at the rear, there is a factory flange. And I've talked to DP UK, and one part of my order, one item of my order was that I sent them this factory flange, and what they did is they turned it for me on a lathe, and they changed it to meet factory Mercedes drive shaft flange. And actually at that point there are two options, because W463 they had that classic drive shaft like this one with U-joints, and there was also CV joints. So when you are swapping in W463, you have to obtain whether you have that classic drive shaft or CV joints. Well, in my case it was classic U-joints. Alright, so issue number 9 is connection between gearbox and transfer case. And this is fabricating your own drive shaft, custom drive shaft, and I would call it yet another critical issue after proper rear gearbox mount. And this is yet another complex story. So the BMW gearbox is like 17 centimeters longer than a factory gearbox, and this drive shaft is like, well, 45 centimeters longer. And what you can see is that drive shaft consists of one U-joint, length compensation, and yet another U-joint, and each individual part has its own length. I mean, like this is 9 centimeters, then this part also has its own minimum length, and there is yet another minimum length, and each size of the drive shaft has its own minimum length. And to build drive shaft that big, I mean not long but big in a diameter, you need some minimum space. And once I installed this BMW 37DZ gearbox, I realized that I have really very small space between transfer case and gearbox, and there is actually a reason for this, because this is W463 model, and what they did in W463 is that they made it all-road vehicle. And the consequence was that they had to also install a third differential locker in a transfer case, which in consequence got much longer. So the transfer case in W463 are much longer than, for example, in W460 or W461. So this is really critical when you want to swap into a BMW 37DZ. It's much worse when it comes to W463, because you end up with really limited space to produce, I mean to fabricate your own drive shaft. So I calculated that the drive shaft should have 273 millimeters in length. I mean that new drive shaft. And in Warsaw there is actually a place where they do that. So this is a place that I like a lot, because it's like you go there you say what you need, and it's done in 2-3 days. And they fabricated a custom drive shaft for me with these flanges. They also rebuilt my front and rear drive shaft. But after they did that, I mean after they fabricated a custom drive shaft, well, I went to pick it up, I came home and I started to fit it. And it turned out to be a fail in one area. So the drive shaft bolted perfectly to DPUK adapter. No issues, no problems. So if we would imagine that this is the DPUK adapter kit, so at the side of a gearbox it bolted perfectly, no problems, no issues. But it came problem at the transfer case, and the problem is that this is actually axle flange, and the transfer case flange is a little bit different, so it's like flush here. And once you press it on a spline over here, I mean like so, on the into the transfer case, you've got this washer, and in factory this washer has no chamfer and no pocket. So this is something that I did later, but what you have to imagine is that this is the factory washer, and there is a bolt, so this is just a temporary bolt. The bolt is different, but just to give you an idea, so it goes like this, and then it bolts flange into the transfer case. So this is the stack, like so, that bolts flange, and it has pretty big footprint. I mean, you have to have pretty big pocket inside drive shaft flange to hide this stack. And factory Mercedes drive shaft has pretty big pocket over here, and this can perfectly hide this whole stack. And what happened is that this custom drive shaft didn't have enough pocket over here, so I couldn't hide this stack inside, which turns that I couldn't bolt drive shaft to the flange, so there was a gap, which was a pretty big fail. So after a while, what I did is I went to closest machining shop and I gave the guy 3 things like this, and this of course wasn't machined, so this was like this from both sides, and I also gave him a bolt and a key, or the socket, whatever you call it. And I asked him to make 2 things. First, to make a chamfer, so it will hide inside this smaller custom drive shaft pocket. And I also asked him to make a pocket for me, so that I can put bolt and then bolt it with a key. And he called and he said it's done, And yeah, it's done. So he made it like this is 23 mil, and the key is like 26. So this was my fail, actually his, but he didn't want money, so I didn't ask questions and took it home, because I told him to make 3 millimeters wall here. But once I took it home, I started to look at it, and I realized that even if I would fit this tool inside, this area here would be much bigger, and I assumed this solution to be not reliable. I mean, I would have pretty big surface of 3 millimeters, and I didn't want to continue with this solution. Actually, because even though I made this chamfer here and I hide this bolt inside this pocket, it was not enough to hide in that smaller custom drive shaft pocket. So what I did, I bought this flange. So these are my old flanges, but I bought a new one, and I went to yet another machining shop. And what I did, I asked them to make a spacer for me. So they cut it like this, I guess with the angle grinder, and then they put it on a lathe, and then they made a spacer from this flange, and this is like 6 millimeters. And what's important in this task is that this is a lip, and this lip is super important because this is, I would call it male fitting, and in the drive shaft you have a female fitting. And what it does, these two parts, they perfectly center themselves against each other, and the bolt job is just to bolt them tightly together. So the main problem of this, well, it's super simple problem for a machinist, is that once you have to turn it flush, and then you have to make a female fitting, because the stack goes like this, that this is the flange of custom drive shaft. So here you have a spacing, so this spacing has its own male lip, so it fits. Then in this spacer you must have a female fitting, and then it comes transfer case flange with a with this stack like so, and then thanks to this spacer this entire stack can hide in that smaller packet of custom drive shaft. So this is the solution that I came with, and if I have to be honest, it took me some time to sort it out. So issue number 10 is about a revolution sensor, which in my G-Class is located down there under the starter, and it bolts to oil pan. And the problem was that in this DPUK adapter plate there was no space for this sensor to go through. But I guess this is pretty easy. Well, one of the easiest problems to sort out, because I just took my magnetic drill and made a cut in this adapter plate so that I could fit this revolution sensor. So this is actually really easy to sort out. So issue number 11 is about gear shifting, because when you swap gearbox, you must have possibility to shift your gears, which is pretty obvious. And what I did is I bought a DPUK solution again, and I find it a really superb solution. I mean the bottom part of this solution, and the bottom part of this solution bolts directly to BMW gearbox, and I would call it really perfect product. Then they also sent me this, and this is supposed to bolt to the bottom of cabin with these 4 bolts, and then this rubber boot goes like on the top, and this goes through. And this is something that I guess I don't understand, or it does not fit to my needs. So the problem is that I made a body lift, and look, how to explain, the pivot point of rotation in BMW is like under the body. This hole must be really low if you want to have a possibility to shift like with the all gears. But once I made a body lift, so I lifted the body like, I don't know, 40 millimeters, then this hole gets too small to shift the gears, because this gear stick will hit that hole. So I guess this is too small. So I started to search for another solution. There are actually 3 things more about this. So it's too short for me. Actually, this is not a problem, because it is very easy to make this actually longer. So this is not a very serious issue. I didn't like this handle much. It's aluminium, it's small, and it's actually pretty cold. So this is something that I'm not the biggest fan. But these are really small problems. This boot is actually super flexible, and what's good about it, that once you shift, it will not throw away gears, because once I started to search for my own solution, I bought a couple of these boots, and I realized that some of them were super hard, and once I shifted into first or third or well, whatever gear, it was so hard that it was throwing out my gears, so I ended up in neutral. So this is well, actually sub-issue of this gear shifting issue. And now I will show you how I sorted this out. Alright, so this is the bottom portion of DPUK gear shifting mechanism, and this is really great solution. I mean, it clicks really perfectly, like so. So this is a third and this is a fourth gear. I guess this is a first and third, 5th and 6th, and this clicks really super nice. So what I did is I fabricated this steel plate with this steel round lip, which is bottom mount for my new and bigger rubber boot. And this entire lip is all around and in the center of this gear shifting, and well, this is really clicky. Now this is also a pretty clever solution from DP UK. So this pin is like 14.8 mil, and you can see that there are 8 O-rings, and inside this gear stick there is a hole, and this hole is a little bigger than 14.8. It's like, let me, oh, what a fail. Okay, so this is I guess 15, so it's just a little bit oversized, and you just press it in, and yes, there is also a hole, so you secure it with a pin, and this is something that I fabricated. So I went to a machining shop and I asked them to turn such a gear stick for me. So I've also bought this SKF rubber boot. This is for a drive shaft, and it's really big, and it's super soft, and it's not throwing out gears. It can be cut here, so you can adjust it to your own diameter of gear stick. This is the part number. This is SKF, and again part number. So this is something that I made my own, so it was pretty easy task for the machining shop, and to keep consistent I've also made the same gear stick for the transfer case. Alright, so finally, like I said, this is my transfer case gear stick, and I made it the same idea, and just to show you how it's working. So this is first, second, third, fourth, fifth and sixth, and reverse, and what's most important, that there is no conflict with the factory handbrake. So you can see that there is pretty big space between. So this is first, and now this is reverse, and this gear stick does not hit handbrake. So once again, I really like it in comparison to my previous gearbox. Issue number 12 is about regearing differentials. So I would call it indirect issue, and I would say it's critical and complex as well, and most likely when you swap gearbox you will end up with different gear ratios. So if you do not calculate it before swap, you can end up being pretty much disappointed. Alright, so now let me try to explain you best I can with my not native English this calculator. So my goal is to cruise on a highway with 2500 RPMs, alright? So I've gathered two configurations or two setups or two factory setups. So this is G350 turbo with OM603 and 136 horsepower on 30-inch tires, and this is G300 OM606 177 horsepower on the same wheel size. So these are two different factory setups, and this is actually a setup of automatic gearbox. So in G350 on first gear you have this ratio and then this ratio on the second and so on. So the fourth speed is 1.0. Now in transfer case on road you have 0.87 and in axles you have 4.11. Now it is pretty good to calculate the total gear ratios on each gear. So this is pretty simple. So to calculate on first gear, what you have to do is that you have to multiply 3.87 by 0.87 and by 4.11. And the same is like on the next gears, right? So if I would like to travel on these RPMs, I would speed 96 kilometers on fourth gear. And the same situation is with this setup, so it works the same. So the difference is in axle gear ratio. So this one G300 has higher axle gears, but it has overdrive in automatic gearbox, right? So what's interesting is that they have different setups, but on 2500 RPMs, right? They travel on very similar speeds. Alright, so now let's focus on these two setups. So this first setup is my configuration before engine and gearbox swap with 35-inch tires. So what you can see over here is my manual gearbox, 1.05 gears in transfer case and 5.29 in axles, which gives me all the total gear ratios on each gears. So if I would put like 2500 RPMs, I will go 92 kilometers per hour on fifth gear in my old configuration, right, with OM603 113 horsepower. If I would speed up to 3000s, I would go 111. But my experience is that this old engine really was so poor that the fifth gear was only for speed maintenance. So it did not accelerate at all on this 5 speed. And 3000 RPMs, well, it was pretty loud. So when I swap and I wouldn't regear, what you can see, if I would keep my 5.29 axles, gear axles, I would travel 89 kilometers per hour on 2500 RPMs, and this would be too less. So what I did, I regeared to 4.375, and these gears come from G500. I've also obviously calculated total gear ratios on each gear, and what you can do is that you can compare your new total gear ratio to your previous. So what you can see, 23.6 is greater than 21.4, which means I will have stronger first gear and a little slower, right? 17 compared to 19. And so it goes up to fifth. So the fifth gear is also stronger than the old configuration. So the speed will be slower. And then when it comes to sixth gear, I have little less total gear ratio compared to old fifth gear, which will give me 107 kilometers per hour on 2500 RPM. And what I can tell you is that I've already done 120 kilometers with this new setup and this new car, I mean rebuilt car. And what I can tell you, it drives really nicely. And there's this new engine, OM606, with this manual injection pump, is strong enough to accelerate on 6 gear. So I'm really happy about this. And what I can tell you more is that when you plan to make regearing, this should be done by a professional or maybe even experienced professional with a proper tools, and this must be done with a precision up to hundreds of millimeters. So you can do it yourself, but after some millage your new gears can be destroyed. So I've made a video about regearing and how it should be done. I've recently added English subtitles, so I will add a link in description about how to regear. And I also advise to make this calculator, I mean to calculate your gears before you start swapping, because making this calculator will cost you nothing and you can fall into troubles. I mean, of course you can be lucky, but you can also fall in troubles. To summarize, I discussed in details 12 issues concerning swapping BMW GS6-37DZ gearbox into Mercedes W463. If you came so far, you must be super patient. If you plan to swap this gearbox into your G, I wish you good luck. In next video we should see on the road, and for now, thanks for watching.